Ever wondered how some machines seem to learn and adapt over time? That's where LORA, or Low Rank Adaptation, comes into play. In the realm of artificial intelligence, LORA is a crucial concept that helps machines to learn from their experiences and adapt their responses accordingly. It's like the secret ingredient in the recipe of machine learning that makes the dish all the more savory. Now, to comprehend the essence of LORA, we first need to understand the basics of machine learning. Imagine a toddler learning to walk. The child stumbles, falls, gets up and tries again, until the act of walking becomes second nature. Similarly, machine learning is a method of data analysis that automates the building of analytical models. It's a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. However, for machines to learn effectively, there is a need for adaptation. Just like a child adjusts its steps based on whether it's walking on carpet or a slippery floor, machines also need to adjust their learning algorithms based on the data they encounter. This is where LORA steps into the picture. LORA is a technique that helps the machine to adapt its learning process. It's a bit like a tutor who identifies a student's weak areas and then tailors the teaching method to strengthen those areas. LORA helps machines to identify patterns in the data they receive and then adapt their algorithms to make better predictions or decisions based on that data. In the grand scheme of artificial intelligence, LORA holds a pivotal role. It's the cog in the wheel of machine learning that ensures the wheel keeps turning smoothly, adapting to the terrain it encounters. It's the tool that empowers machines to learn from their experiences, adjust their algorithms, and improve their performance over time. So in essence, LORA is an integral part of how machines learn and adapt. But how does it actually work? Diving deeper into LORA, it's a method that allows machines to learn from a small set of examples and generalize to a larger set. In the realm of machine learning, this is a significant leap forward. But what exactly is LORA? LORA, or Low Rank Adaptation, is a method that minimizes rank approximation. In simpler terms, it's a way to simplify complex datasets, making them more manageable for machine learning models. By reducing the rank or the complexity of a dataset, LORA allows machines to understand and learn from the data more effectively. Traditional machine learning methods often struggle with large, complex datasets. They can get lost in the noise, unable to distinguish the important patterns from the irrelevant ones. This is where LORA comes into play. It cuts through the noise, highlighting the essential patterns and making them easier for the machine to learn. But that's not all. LORA also overcomes another significant limitation of traditional machine learning methods, the need for vast amounts of training data. With LORA, a machine can learn effectively from a small set of examples. It's able to generalize from these examples, applying what it's learned to a larger set of data. This makes LORA especially valuable in situations where training data is scarce or expensive to obtain. So, LORA is not just about simplification. It's about making machine learning more efficient, more effective, and more accessible. It enables machines to learn from less data, to learn more quickly, and to learn more accurately. Therefore, LORA is a powerful tool that enhances the learning capabilities of machines. But how does it apply to LLMs? LLMs, or low-level machines, are the perfect candidates for LORA. Let's explore why. To begin with, low-level machines, or LLMs, are fundamental components in the realm of machine learning. They are the algorithms that function at the most basic level, processing data and making predictions. They build the foundation for more complex machine learning systems, and their efficiency is crucial to the overall performance of these systems. Now let's talk about how LORA, or Low Rank Adaptation, fits into the picture. LORA is a method that is designed to optimize the performance of machine learning algorithms. It works by identifying and exploiting the low-rank structures in the data. This essentially means it recognizes patterns within the data that can be simplified or reduced to make the learning process faster and more efficient. So, how exactly does LORA benefit LLMs? Well, when applied to low-level machines, LORA serves as a power booster. It enhances the ability of these algorithms to recognize patterns, which in turn improves their ability to make accurate predictions. Moreover, LoRa's ability to simplify data structures means that it can significantly reduce the computational requirements of LLMs. This makes these algorithms quicker, more efficient, and more adaptable to different types of data. The beauty of LoRa is that it doesn't just improve the performance of individual LLMs, it can also be applied to systems where multiple LLMs are working in tandem. By optimizing each LLM, LoRa enhances the overall performance of the system, making it more effective at processing and interpreting data. In essence, LoRa acts like a fine-tuning tool for LLMs. It refines their learning process, making them more capable of identifying patterns and making accurate predictions. This not only improves the performance of the LLMs themselves, but also the larger machine learning systems they are part of. In other words, LoRa refines the learning process of LLMs, making them more effective and efficient. Now let's look at some real-world applications of LoRa. From self-driving cars to voice recognition, LoRa is changing the game. Let's delve into some of these applications. In the realm of autonomous vehicles, LoRa, or Low Rank Adaptation, proves to be an indispensable asset. It aids in the processing of vast amounts of data from various sensors like LiDAR, radar, and cameras. LoRa's capability to adapt and learn low-rank structures from high-dimensional data enables these vehicles to navigate safely and efficiently. It facilitates real-time decision-making, allowing the vehicle to react appropriately to dynamic road conditions, from recognizing traffic signs to detecting pedestrians. Now let's shift gears to voice and facial recognition systems. These technologies have become increasingly prevalent, from unlocking our smartphones to interacting with virtual assistants. LoRa plays a significant role in these systems. It helps in accurately identifying and adapting to different voices and facial features, even in varied environments. This adaptability comes from LoRa's ability to extract relevant features from high-dimensional data, ensuring that your virtual assistant understands your command, or that your phone unlocks only when it recognizes your face, but that's not all. LoRa is also instrumental in other advanced technologies. For instance, in the field of bioinformatics, LoRa is used to process complex biological data, helping researchers identify patterns and make significant discoveries. In finance, LoRa aids in the analysis of market trends and risk assessment, thereby assisting in strategic decision-making. The beauty of LoRa lies in its versatility. It can be applied across diverse fields, improving the accuracy and efficiency of various systems. Its capability to adapt and learn from high-dimensional data is what sets it apart and makes it a crucial component of these technologies. So, whether you're using a virtual assistant, driving an autonomous vehicle, or even making a financial investment, chances are LoRa has played a part in it. It's fascinating to think about how this technology, often unseen and unheard, is silently revolutionizing our world. As we can see, LoRa is not just a concept, but a driving force behind many of the technologies we use today. LoRa, an unsung hero, quietly revolutionizing technology. So what have we learned today? We began our journey by exploring LoRa, or Low Rank Adaptation, a unique technique in the realm of machine learning. We discovered that it's not just another algorithm, but an innovative method that allows us to extract useful information from a sea of data. It's all about finding patterns, deciphering complexity, and making sense of the incomprehensible. Our exploration took us deeper into the inner workings of LoRa. We found out that it operates on the principle of low-rank decomposition, focusing on the most significant components of data while discarding the rest. This approach not only simplifies the processing, but also enhances the accuracy of predictions, making it an optimal choice for machine learning models. Then we ventured into the fascinating intersection of LoRa and LLMs, or large language models. We learned that LoRa is like the secret ingredient that supercharges these models, enabling them to process and understand language more efficiently. It's like teaching a computer to read between the lines, to grasp nuances and to understand the context, all made possible by the magic of LoRa. We also delved into the real-world applications of LoRa, exploring how it breathes life into our smart devices, making them more smart than ever before. From voice assistants that understand our commands to recommendation systems that know our preferences, LoRa is working tirelessly behind the scenes. It's shaping our interaction with technology, making it more intuitive, personalized, and efficient. In essence, LoRa is transforming the landscape of machine learning and technology. It's an unsung hero, working quietly in the background, making our machines more intelligent and our lives easier. It's the unseen force that's constantly adapting, learning, and evolving, all in an effort to understand us better and serve us better. Remember, every time you interact with a smart device, you're likely experiencing LoRa in action. It's shaping our technological landscape, one adaptation at a time.